Hi, this is Aaron with iBoard Repair. Today I'll be showing you the process of reballing an iPhone 16 Plus motherboard interposer, aka the sandwich. And in this case, we're also going to be doing a full RF board swap. And what that means is the radio frequency half of this motherboard has gone bad, and I'll be replacing it with a good one. And I'll also need to move over the paired chips that are on that board so they stay with the original CPU. So let me show you where I'm at so far. I've already split this motherboard apart. This is what it looks like normally. And using a heating platform, I've separated them. These are the original, and I'll replace it with this donor here. And this little chip right here, that's paired, so I have to move that over. And this still is a data recovery, but this is a passcode-free, privacy-first data recovery. And what that means is the customer has not given me their passcode. They have sensitive information on this device, or they just have information that they want to keep private and they want to transfer it themselves. So my job is not to pull the data directly, it's to give them back a working phone. This phone had originally died, and the root cause was on this RF board, which I will show you. These are the two halves of the motherboard. This like little junction that connects the two halves. This is called an interposer, and a lot of people will refer to this as the sandwich. It's like a sandwich motherboard. And by the way, sorry if you hear my children in the background. I do work from a home office. So this iPhone spontaneously died, and the customer needs it to turn on again. And they don't really care about the phone, but they need the data that's on the phone, and they need to transfer it themselves. And what I found was some sort of power surge had happened on this RF board. So the radio frequency board controls a lot of things, but the important thing that we're going to worry about here is this chip. This is called the baseband CPU, and this is paired to the CPU here. So what we'll have to do is remove this one. This is the donor board we're gonna exchange this with. So we're gonna reball this and we're gonna recreate the sandwich here. But if I did that without moving over this chip, then the service or the LTE would never work on this phone. So I'll have to remove this one, clean up these pads, remove the one that's from the original board, and clean the pads underneath the chip and reball the chip and then place it onto this board. But again, what this problem was some sort of power surge, and it took this phone out completely. It shorted the main power rail to ground. It was almost surely no fault of the customer. Sometimes things like this just happen on iPhone motherboards. So that's enough of a preface. Let's go ahead and get started. First things first, I'm going to prepare the chips. I think that's a good starting point. So I will take off this original baseband CPU. I'll reball it and then prepare this one. After I do that, I'll prepare the sandwich pads on this side. Then I'll do the same thing on the donor board here, and then we can put everything back together, and we can do some minimal testing that we can do without the passcode. The first thing I'll do is remove the underfill around the outside of the baseband CPU. I'm using temperature 305, but it doesn't really matter. This board is going to be trashed after this, so I just need to extract this chip from this board so we can transfer it to the donor. I should also mention that a lot of the time in most other models, I'll also have to move over another chip, the Wi-Fi chip. On this model, the Wi-Fi chip is on the CPU board, so it's already on the board that's going to be where it needs to be to talk to the CPU. So we're lucky in this case. So I'll go ahead and remove the chip now. With the chip removed, I'm still gonna have all of this underfill, and I'll need to remove it first before I can reball the chip. If you're another tech, feel free to recommend me a good chip holder in the comments. My chip holder is terrible. I'm just the type to get caught into my ways, and I've used it for so long. I don't know which one I should, or what I should replace it with. Okay, underfill is removed. Let's freshen up these pads. Some of them are gray and mostly missing solder. I'll try some solder paste instead and heat it with a hot air and see if that gives me better results here. Yeah, that did the trick a lot better. And now I'll go ahead and remove all of this extra solder that's on here, and it will be ready to take a reball after this step. A couple of these pads are still gray, like right there, but when I'm removing it with the solder wick here, it's gonna brighten up the rest of those gray pads, any of them that are left. I have a couple different lighting options here, and sometimes it's better to turn off the ring light so we can get a more clear view here. And with that light off, this looks perfectly fine to me. So let's just wipe it off and reball it with our reballing stencil. And now is a great time to turn the LED ring back on. As you can see, Makes it a lot easier to see once it's in the stencil here, or under the stencil. I do like to dry the solder paste just a tiny bit with the hot air and then pat it dry. And that gives it a pretty good consistency when you're trying to spread it on the stencil. These holes are small and close together as opposed to some of these other ones. Doesn't really make too much of a difference, just noting it. So I'll spread that solder paste onto the stencil, make sure it's nice and even. That looks pretty good. There's a huge variance in the temperatures that people use when they're reballing a chip. But me in particular, I like about 280 when I'm using this type of solder paste, which is 183 solder paste. It doesn't bend the stencil too much, and it still heats the solder pretty quickly. All of the balls formed, but not all of them attached. So let's go ahead and just add a little bit of flux down. I don't always add flux just for the sole purpose of it makes the stencil dirtier and I have to clean it, but it does make it a little bit easier. Let's just move this solder ball over a little bit, hope it onto the right spot. And then over here, this one probably just needs a little more flux. Okay, this looks fine to me. And I'll go ahead and reflow these solder balls on the chip one more time to make sure they're firmly attached. I do this circular motion because it, um, it doesn't make the flux fall off of the chip, it just goes in a circle. And if you don't do that, the flux will just run off of the chip. And the first process is complete. I just need to clean this up a little bit and we can move on to removing the baseband CPU from the donor RF board. Here is the donor RF board that we will be transferring the chip onto. So let's go ahead and start by removing the underfill. I'll want to be a lot more careful on this board because this is going to be the board that's given to the customer and used in the final end result. Okay, I'll bump this up to chip removal temperature, which is, I use about 370 a lot of the time. So let's go ahead and remove this chip now. Looks okay. I'll probably have to mask down that little exposed copper area. And I'll go ahead and just start fixing these pads now. First, I'll have to remove the underfill that's left over on the board that was underneath the chip. And to remove this, I'll just use my soldering iron. There's a couple different ways to do it, but I just like to use my iron. And I just do a bit of scraping with my soldering iron. So it's both like melting the solder pads, it's reflowing it with lower melting point solder, and at the same time I'm scratching away this underfill. That's one of the reasons I do really like my the shape of my soldering iron. I believe it's called a chisel tip, and it may come with some starter packs, but most of the starter like soldering iron tips that come with the stations, I don't think this is a typical one within them. But this is just what I like, and a lot of technicians have their own preferences, different preferences. That looks just fine to me. So I'll go over it one more time with my soldering iron with leaded solder to fix these pads, and once it has the leaded solder on them, then I'll go ahead and remove it completely with the soldering wick. All right, and finally, I'll go ahead and flatten these pads now. You can use an iron and a solder wick, but I prefer to use hot air. That looks pretty good. I'll just clean it up now. Some isopropyl. And this should be ready to take a chip. I could clean up some of these solder pads, like some of these vias, and this looks like it's just a ground plane that's a little bit exposed. But I don't really think the chip is going to have any trouble connecting to where it's supposed to connect. So I'll just clean this up a bit, and then I'll just place the chip down. The original baseband CPU will go onto this donor RF board. I like to preheat the board just a little bit with the hot air, And I only do that so it makes the flux that I'm putting down now melt right away. If it's not pre-melted, it will tend to like pull the chip out of the right spot. The one good thing about all of these components being so close to the IC is that you have a little bit of an easier time figuring out the spacing of where the chip is supposed to go. Most of these big chips like this have even amount of spacing all the way around it from all of these components. That looks pretty centered to me. I like to give the chip very direct heat when I'm first applying the heat. And this will like almost tack it down for a moment. And then I can start to do circles and that will finish it and push it into place. That looks pretty good. I can't really see underneath the chip, but it looks pretty good. I'll go ahead and put this RF board and the CPU board into a testing jig and make sure that it's still turning on normally. And actually first, let's not forget to transfer the baseband EEPROM, which is a serialized chip. The baseband chip itself will not work unless it has its original EEPROM. So I'll take this one off of the donor board first. And I'll take the original RF board's EEPROM off and transfer it over now. For this one, it's smart to turn down your airflow because we can't lose or replace this chip. We need this chip. Okay, that looks good. So I'll go ahead and test this out now and make sure it's still booting normally. Okay, well, this looks pretty good. Here's the testing jig. Okay, so this all looks good. My next step is going to be to reflow all of these pads along the outside here, these interposer pads all around the outside of this RF donor motherboard. I will reflow all the pads with solder and then I'll flatten and remove all of the solder and that will prepare it to take the CPU board, which is right here. This board I'll do the same thing to, but then I'll reball this board with a stencil and I'll put them all together on a heating platform. So flux will go down. I'll get some solder onto the iron. I think I'll bump up my soldering iron a few degrees here. My normal solder iron temperature is actually 350, which I think is probably lower than most people might use. And that's why you'll sometimes see me supplementing my iron with some hot air. This is just a personal preference, and it's not necessarily the best or a better way. And I do move my soldering iron temperature around a lot more than I think most people do. I'll have different temperatures for different things that I'm trying to do. If I want to take solder off or I want to put solder down, I have different temperatures for that. In general, if I want the iron to really stick to something I'm touching, I'll turn down the temperature on my iron a little bit. So from 350 to say 300, and then it makes it a little bit easier for the solder to stick to whatever I'm touching if I want to like get a blob of solder on a capacitor or a filter or something like that. That looks okay to me. I'll go ahead and use a solder wick now and wick away all of this solder clean. And I'll use my hot air for this one. I'll sometimes use an iron depending on the situation, but in general, I like to use hot air when I'm wicking. And again, this is just personal preference. Everyone does it their own way. Okay, this looks pretty good, so I'll just clean it up. Some isopropyl, and then we'll reball the CPU board. It's important to get as clean as possible because we're going to be putting flux down again at the end of the process, and we don't want flux all over the place on the end product. So I'll do that same process to the CPU board here. I'm going to reflow all the sandwich pads with lower melt solder, and then I'm going to remove all of that solder, and then I'll use a stencil to reball this board. This whole process on the CPU board is a little bit easier because this is the side that actually has the interposer, and that means the pads are all raised, so I'm not right next to any of the other components. My iron was struggling a little bit on the RF board, so I have another chisel tip that's just much bigger and fatter, and I like to use this one on this board because I have a lot more space to use it and it will flow the solder a lot easier. I think in this case it will be easier to just go ahead and wick it with the iron itself. I have a lot of room. I don't really have to worry about it too much. Let's see how it goes. Yeah, that looks fine. I'm having trouble seeing this section, so I'm just going to go ahead and switch back to hot air for maybe the rest. I like to use the iron by the CPU just to have the least amount of heat as possible there. Okay, this is also looking pretty good, so I'll go ahead and clean it up. And I am realizing now most of the time when I do sandwich reball, interposer reball, it's usually the RF board that has the actual interposer. So the fact that the RF board or that the interposer is on the CPU board kind of changes things, because normally I'm comfortable heating with just the heating platform, doing the majority of the work, and me supplementing with a little bit of top air to get these boards to come together. But I'm realizing that's not a safe method, because the board that's closest to the heating platform on the 16 Plus specifically is going to be the CPU board. And this CPU is still underfilled. This hasn't been a CPU swap job. It's been a, more standard data recovery. And if I take too much, or if the CPU takes too much heat, or even the NAND, which is even going to be closer to the heating platform, I might float those components. So I think I'm going to have to heat from the top in order to get these boards to sit together. I think that's going to be the safest method. Maybe a little bit of heating platform. Even the way that I reball the interposer itself might have to change a little bit when I have the CPU board on the bottom with the interposer. Okay, so I've got the board into my stencil, my magnetic stencil holder here. There's two ways I can do this. I can do the technique where you just really quickly pull it off and hope your solder stays on the board. I've never been great at that technique. Seems hard. And let's go ahead and apply some solder paste to the stencil now. My paste is already quite dry. I think it will be okay to spread as it is. If it's too dry, it's hard to get it to stick to the board. It's not too bad. Maybe it's a little wet still. This looks pretty good, so I'll go ahead and just clean up the extra paste. And then we can see if this laid down properly. And I'll get the last bits of residue with my cotton swab here, my Q-tip. Okay, idea is to just peel it fast. And it should stay on. Should on this side instead. Well, definitely didn't stay on all the way. Can never quite get that method to work. It's probably just my solder paste. Some of it looks okay. I guess I'll just go like a combo technique then in this case. Obviously it's not all there, but some of it is, and that can give me a good like starting point. I'll put this part back on afterwards. See if we can get the paste to remain the same. It's a little scuffed. I think it can still work though. Down here is kind of the hardest sections anyway, to get like a little boost right here. It's fine, or I get a little like establishment, I should say. This top section is really bad at staying even on the stencil itself. It's just not cut super well. I might want to look for a different brand. I saw at least a couple of these top ones probably grab a wrong bit of the solder. Not too bad. This is not done. I just kind of did this like a hybrid method. So I have half of the solder on here. I still need to get the other half on here. In the meantime, I need to clean this up so it's not sticky, I think. Doesn't really matter the technique, the end result is what matters, and as long as you can make sure that nothing is wrong, it doesn't really matter what you do. Just make sure you don't let any mistakes stay on the board, you fix everything. I'm very fluid with my repairs. If you haven't noticed, I change up my techniques all of the time. So let's go ahead and use this actually. It may work even better in this case. I've put the big magnetic like clamping thing down onto this board now, and I'm just going to slowly heat each section and see if I can get the rest of the solder that's left on the stencil to join with the solder that's now on the board. Where did that come from? It's a huge solder ball. Jesus Christ. I think this section is the hardest. Okay, this looks really good to me. I think it's probably pretty close to perfect. Yeah, I don't see any solder paste left on the stencil, so that's good. Means it's all on the board. And nothing, I saw like a couple of extra solder balls floating around, but I didn't know where they came from. Maybe it's just solder came from somewhere. I didn't really see any pads that looked messed up. So I'll apply a little bit more flux and just go ahead and reflow all of these pads. For the most part, I'm pretty happy with how they look. I will grind them down just a bit to make sure everything stays even. Okay, so we can take a look at all of these. They look pretty good. An easy way to see if any of them are oversized is to just take the board, flip it over, put on a flat sheet of paper, and grind it down. And any of them that are too big will get a flat surface. So let's do that real quick and see what we find. So let's see what was grinding. Right here, the ground is way too big. And the reason the ground is way too big, because it looks like those two pads are too small. Is that right? Yeah, so let's see what those are real quick. Well, first let's look at everything else. What else was too big? Was that it? A bit too big right here. We got one that's a bit too big over here. The only one that's really jumping out at me like crazy are those, the ones by the ground pads. Everything else looks like it will probably be okay. So where was that at? Right here. So first I want to see what these two pads are and if they're important, and even this one up here. Okay, this is a little confusing because I'm not seeing any of these like triangle shapes here. There's at least two. Oh, on this side there are, but let me show you what I have on my board again. Here's my donor board. Yeah, those are all separate pads down here, so that was definitely not correct. Now I gotta like double check all of those types. So this one is here. Good. There's two right there. Good. There's one up here. Good. One right here. Good. 1, 2, 3, 4. Okay, all the rest of them are good. But these three right here are not supposed to be connected. So that's our main problem. Let's just rework this whole little section here to be safe. I think that's really all I need to do. So let's just fix this one spot, and then I'll grind it a couple of more times to make sure that anything that's just a little oversized will be a little bit smaller. But I think we're okay after this. No, it looks like I missed like 4 of them. I wasn't paying close enough attention. Whenever ground is too big, I make sure I get rid of it because I don't need all the ground connections and I don't want it to prevent pads next to it from connecting. Just take off a little bit of this ground here. Okay, this looks pretty good. Let's go ahead and set the top board finally and get this thing finished up. Took a bit longer than I would have liked. I don't think I'm going to heat from the bottom this time. I think I'll purely heat from the top. I have much less chance of damaging my NAND or my CPU if I'm heating from the top. First, I'll kind of preheat the board so when I apply flux, the flux will automatically melt. I just like working with slightly melted flux for the most part. And here is the donor RF board that we've already prepared. So I'll go ahead and line these up first as carefully as I can, and then I'll start to heat from the top. That looks pretty good. There's essentially no underfill on the top board whatsoever, so I don't really have to worry about overheating it. There was on the baseband CPU, but that was cleaned off when I replaced it, or when I swapped it. I'm going to go ahead and do this part outside of the microscope to give myself a better view. I'll add a bit more flux. This looks pretty good in my opinion. Crazy. There's still a couple spots that are not fully melted. I'm just going to touch up a few of the spots that maybe they can use a bit more. Good. Over here for sure. So I can touch these up just by squeezing individual spots and waiting for that spot specifically to melt. And then I hold it while it's melted for a second, or while it's cooling, so it stays together once it cools. There we go. Okay, I think this looks pretty good. I'm going to go ahead and clean it up, and then we can see if it's booting. I'll put it into the housing. Okay, first things first, I can make sure it's giving me normal current draw when I prompt it to boot. So I'll turn on my DC power supply here. I will touch the probes to the battery connector. We're seeing a 0 amp draw, which is normal. I will short the power button line with my tweezers to prompt it to boot, to prompt the phone to boot. And we're seeing already what looks like a normal current draw, so it should be booting up. So let's just put it in the housing and give it a last inspection here. While editing the video, I realized I lost the final testing scene, so I'm really glad that we had that DC power supply testing as the final shot at least, so we can see that it's working. And a point to that, the baseband transplant getting the service to work was really just to restore as much functionality to the phone that I possibly could. However, it's not actually needed for the customer to pull the data from the device. They need that phone to turn on and to be stable. And for the record, I did see that phone turn on and be stable. I just lost the footage. They need that phone to turn on and be stable, but they don't necessarily need the LTE to work. We already know the Wi-Fi chip was still on that motherboard, so Wi-Fi is almost surely working, even if the baseband didn't. And aside from that, there's other methods to get connectivity to the phone again. For example, I use a USB-C to Ethernet cable when I need to give a service to phones that otherwise wouldn't have it. So there are other methods. I did all of this work just to be as complete as possible. But in any regard, I know this job is successful and the customer is going to be able to pull their data from it themselves. So this is a successful privacy first, passcode free data recovery. Thanks for watching.